everyone, and welcome to the fourth Ungleich Tech Talk. Today's topic is IPv4 as a service via IPv6. So first of all, let me introduce a bit the problem that we want to solve. So if you're in need for a public IPv4 address, there's one question is like, what is the best way to get a public IPv4 address? Obviously, you could argue like it depends on where you are, it depends on like which system you are on, if you're on a server, if you're on a notebook, if you're on a VM, if you're on a Raspberry Pi. But for me, I try to have things simple. So I was looking for something like a universal way of getting a public IPv4 address. That's like, doesn't matter like what it is, like if it's on a server, fair enough. If it's on a mobile phone, fair enough. It could always be the same way. And this is what we have been building here at Ungleich over the last couple of months. And there are some people already using this. So this is not completely brand new anymore. But it's still like, for me, a very exciting service because it is IPv4 as a service, but via IPv6. And I will explain to you in a second why via IPv6 and why this is actually really, really cool. Before I do this, if you're not so much familiar with NAT64 and how it works, I recommend to check out the previous Ungleich Tech Talk, just that you feel a bit more comfortable when we go through some topics here. So the general approach is, in theory, to have a public IPv4 address, you just need to have a router who brings you that IPv4 address. So, well, this can be your ISP, this can be, basically your ISP. Bad example. But anyway, the point is, in theory, you just need to have a router with enough public IPv4 addresses that says, here's a route, I will just route the IPv4 address or a network to your device. The problem is when you're behind NAT, and especially in a CGNAT environment, there is no direct IPv4 route to your end device anymore. And while we have discussed a lot about IPv6 in general, this is one of the reasons where IPv6 really shines, because IPv6 is real end-to-end connectivity, and CGNAT is really breaking this concept of one host can reach another. And this doesn't stop even when you are in the pure IPv4 world. So even if you like ignore and say like, well, IPv6, I don't need it, well, you can't do things anymore because you have CGNAT. And it's a real problem. The IPv6 world, on the other hand, has developed like very early a very interesting concept, and that concept is called mobile IPv6. The whole motivation behind mobile IPv6 is the following. Assume you have a home network. That doesn't have to refer to your literal home, but let's say your workplace is your home network, or even your home, or your co-working space, or your data center. But you have, let's say, a primary network. This is where your device by default came from or is in. And the IPv6 world developed very early a notion of mobile IPv6, where you would take your home IPv6 address with you anywhere where you go. And there's a concept of a home agent and how you establish connections and how you can use IPv6 for IPsec on top of it. It's quite sophisticated, but it is not so, let's say, present in today's world. So it was more a concept, or it is still a concept that is quite interesting, but not so much present. Basically, that is what we want for an IPv4 address, because I want to be able to bring an IPv4 address, I don't know, to the train, to the car, to my picnic. If I have a webcam at my picnic and I do want to have IPv4, which honestly I don't want to have so much often, but that's not the topic today. But if I want to have an IPv4 address, I would like to be able to bring it anywhere. And yeah, this is not so easy. So how do we solve this? Well, I think I talked about the IPv6 VPN from Ungleich before, and I also talked about NAT64 before. And now we're just gluing those two together. A short recap: the IPv6 VPN, it's a service from Ungleich. It's a WireGuard based, and you get basically a static /48 IPv6 network routed to your end device. So you have 80-bit of IPv6 address space that you can use. And practically seen, it gives you IPv6 anywhere. So we have customers in almost every country that I know of. And it just works. However, the IPv6 VPN only gives you IPv6 addresses. And this is not what we're talking about today, because we want to have an IPv4 address as a service. However, what we do at Ungleich is we're using NAT64 to do a one-to-one mapping of an IPv4 address, a public IPv4 address for the matter, to an IPv6 address. So to a particular IPv6 address in your network, in your /48 network, we map an IPv4 address. So how does it look like? In a very, very simplified version, here in the middle you have your notebook, your desktop, your server, your IoT device, whatnot. And this can be accessed and can access the IPv4 internet via a so-called NAT64 translator. Because remember, the end device here is IPv6 only, or only has public IPv6 addresses. Then again, the IPv6 internet can be reached via the VPN, via the IPv6 VPN. So this is a simplified view, and I think there's a bit more to it. Let's dive a bit into the details of it. So here at Ungleich we have a so-called Anycast NAT64 prefix. This is quite a new thing, because so far we only had local NAT64 prefixes. Now we have a global NAT64 prefix, which is 2A0A E5C01E :CC001 /96. So this one is something we advertise at various places in the world for use with with translations to and from the IPv4 world. So for a moment, assume that you have on your IPv6 VPN the network 2001 DB8A :/48. The important bit here is only that you have a /48 network. Here at Ungleich we have a list of commonly used networks, which is linked here, which you can't see right now, but I will add it in the comments. And what we do is, given a /48 IPv6 network, we defined some typical subnetwork addresses that we use. For instance, the B00 subnetwork is something that we defined we quite often use for incoming NAT64. Just recapping, what do we want to do today? What we want to do is we want to be reachable via IPv6. Via IPv4. Via IPv4. Sorry. So, assume for a moment that the public IPv4 address, this is just an example address here. This is a documentation IP address. But assume this one is mapped for you. So 192.0.2.1. Then we can just append it, and this is a really, really cool thing. I think I mentioned this before, but you can actually concatenate IPv4 addresses here into IPv6 addresses, and this is a valid IPv6 address with an embedded IPv4 address. So this is it kind of really twists around all parts of your brain, because I thought IPv6 was colon only and IPv4 was dots only, but now we have this thing in between. This thing in between is really, really cool for transition technologies, because right now we are actually discussing public IPv4 because you actually need, for some applications, IPv4. So what we do is we say we just use this IPv6 address, which looks like an embedded IPv4 address, which it practically is. Alright, so that is all there is to need to know. So you have access to your /48 network, you set up this IPv6 address on your side, and the rest is done at ungleich. Pretty easy, huh? So I'm not satisfied, because I think there's more to it, and I love visual representations. And I have to excuse myself because it is a bit tiny, the next graph. It is because it is a bit complicated, but it is a bit the reality. So I will try to explain a bit in detail. So here in the middle, we again have our end device, the one that we want to make reachable via IPv4. So this end device begins by connecting to the VPN server here in the data center light in Switzerland. With this, it gets an IPv6 network routed. So the VPN server routes it here, and at this stage, the IPv6 internet can access our end device and everything that's behind it. So this can be a router, doesn't have to be an end device, but can like forward things here at the end. The IPv6 internet at this point can already reach us and everything that we configure. It's dashed here because effectively the IPv6 internet connects via the VPN server back to the notebook. So it's basically a bridge here. So, but what about IPv4? And now it's really cool and really interesting. And I even split it here, the NAT64 translators into 2 blocks. So we have one NAT64 translator that I call inbound here on the right side, and one NAT64 translator for outbound traffic. In reality, those are really 2 different NAT64 translators. In practice, they don't have to be, but it's also easier, I think, for looking at it. So let's have a look at how the IPv4 internet can address an IPv6 only host. And it does as follows. So the IPv4 internet connects to the mapped IPv4 address and goes to the inbound NAT64 translator. The inbound NAT64 translator has a table entry that says this particular IPv4 address maps to a particular IPv6 address. So this NAT64 translator here turns the IPv4 packet into an IPv6 packet, and then it just applies usual routing information and sees, okay, this IPv6 address is actually reachable via the VPN server here. Forwards it to the VPN server, and that one forwards it to the end device. So actually not that hard. It's quite nice. For devices in the IPv4 internet, they obviously don't really know anything about this. For them it looks like as if the IPv4 internet was directly accessing the end device here, which might be behind CGNAT, which might be on a mobile device. So literally, I do have a public IPv4 address on this phone here for testing, but it works. Practically seen, the phone thinks it's an IPv6 address, but it is reachable via IPv4. This brings me to the second topic. So at the moment, we know that the end device is reachable via IPv4, via IPv6. Translate there. But how can we use this IPv6 address, which is mapped IPv4 address, for outgoing connections? And this is a bit more tricky, because this computer here wants to connect to the IPv4 internet, but via IPv6. For that purpose, we have created this Anycast NAT64 prefix, which I mentioned just before. This is the 2A0A E5C0 1E C001 and : ABCD, where ABCD stands for the IPv4 address that we want to reach. So this device here will embed the IPv4 address into the Anycast prefix, And with this, it will see, okay, my IPv6 upstream is the VPN server here, which again sees, all right, I have a route to the outbound NAT64 translator, and this one will then translate the destination address that is derived from this prefix here to an IPv4 address and sends it out to the IPv4 internet. So it's a bit of magic here, because you're doing IPv4 via IPv6, but the nice thing is, and this is really something I want to emphasize here, on the end device part, you only deal with IPv6. You don't have to think about IPv4. You just know that there's a specific IPv6 address that is also reachable by IPv4, but you don't configure any IPv4. Why would you? It's not necessary anymore, but you're still reachable via IPv4. So in a summary, IPv4 via IPv6 is quite a model, and also it's a very scalable way for getting IPv6 via, I'm sorry, this really doesn't go in my brain, but getting IPv4 via IPv6. The point is, we can use, and now going back here, we said we use this prefix, the B00 subnetwork /96. The /96 in the IPv6 world corresponds to 32-bit. And if you remember, the whole IPv4 internet is also 32-bit, which means that if you want to have one IP address, two IP addresses, four IP addresses, or the whole IPv4 internet mapped to your IPv6 network, it all works. No. Practical limitation is that at ungleich we don't own the whole IPv4 internet. We also don't want to. But practically seen, you can also say, I would like to have 256 IPv4 addresses, and they can just be mapped directly, stateless, into your IPv6 network, or even bigger. So the other cool thing is you can use it anywhere, really anywhere, independent of your location. It can be like in your hometown, it can be in your data center, it can be on your mobile phone, it can be in a foreign country. So you can say that you take your tablet or your router or anything with you, and you always have the same IPv4 address no matter what way you go. And it also works behind CGNAT, and you can even take your Raspberry Pi and say like, well, I'm using the IPv4 as a service via IPv6 on a Pi, and then you can do all kind of funny things with it. And this brings me a little bit to the conclusion, and the conclusion for me here is IPv6, and I really have to advocate this, IPv6 really makes your life easier, because you don't have to think anymore into small like /31, /30 networks, and then you have a tiny /24 somewhere, and then you scratch an IP address here out of... No. You don't do this. You just think big with IPv6. You have a lot of IP addresses. You always have them. Even with just a single VPN, you get 80 bits of IP address space for yourself. And you can think very easy with IPv6. And that's the cool thing. On top of that, you can also have IPv4, but you don't even need to think about it anymore, because IPv4 is just a little bit smaller than IPv6 and comes via IPv6. That brings me to the end. I hope you enjoyed it. And obviously, this is something that is provided by ungleich, but it can also be built by yourself. You can also do this for private networks if you wanted to. So I hope you got the general notion, and I hope you enjoyed it, and I wish everybody a good time. See you next time. Bye bye.